Imagine if we told you that you exist in a completely different universe, one that you never even knew existed. It might sound frightening, but the truth is, there could be a copy of you or someone you love living in a parallel universe right now. This fascinating concept stems from the theory of multiple universes, where alternate realities exist alongside our own. While some scientists may reject this idea as mere fiction, there is mounting evidence that parallel universes could indeed be real. As we explore the topic of parallel universes, we will uncover what they are, how they may impact you, and the latest proof of their existence. For ages, humans have been asking if other forms of life exist in the universe, but scientists have taken it further and theorized the possibility of parallel universes existing alongside ours, with some even proposing an infinite number of such universes. While it may seem like science fiction, it has attracted the curiosity of many over the years. Imagine a world where the outcome of World War II was different, where dinosaurs still roam the Earth, or where humans never existed. Sounds like science fiction, right? But what if we told you that these worlds, or parallel universes, could actually exist? The idea of parallel universes dates back to 1954, where a Princeton University student named Hugh Everett III proposed a radical theory that shook the world of physics. Everett believed that there are countless universes out there, branching off from our own and existing in parallel. Of course, this theory was met with skepticism and doubts from many, but Everett's many worlds theory aimed to answer some of the perplexing questions that arose from experiments in the field of quantum physics. The implications of this theory are vast and intriguing. It suggests that in these parallel universes, the laws of physics might differ, and the outcomes of historical events could be entirely different. It's a bold and exciting idea that challenges our perception of reality, and one that continues to captivate scientists and enthusiasts alike. If you're enjoying this video and learning something new, please hit that like button. Your feedback helps us understand whether we are creating valuable content for our audience. Quantum physics focuses on studying matter at the subatomic level, which is the smallest level that scientists have been able to observe so far. At this level, quantum matter appears to behave differently and unpredictably, which suggests that there may be other scientific laws at play that we are not yet aware of. For instance, when studying quantum mechanics, scientists discovered that particles like photons can randomly switch between behaving like particles and waves. This peculiar phenomenon is known as the Heisenberg uncertainty principle. Physicist Werner Heisenberg suggested that simply observing quantum matter can alter its behavior. But it doesn't stop there. Another physicist, Niels Bohr, took this theory to the next level, suggesting that quantum particles exist in all possible states simultaneously, and that our observations of them force them to take on a single state at a specific moment in time. It's as if they're juggling multiple identities, and it's only when we observe them that they're forced to choose one state at that moment in time. This might seem far-fetched, but it's a theory that's gaining traction among scientists, and it has huge implications for our understanding of the universe. Everett's many worlds theory presents a different view of quantum matter than Bohr's theory. According to Everett, when quantum matter is observed, the universe splits into multiple parallel universes, each containing one possible state of the matter. This theory has some implications that make some scientists uncomfortable, such as the idea that if death is a possible outcome, there must be a parallel universe in which you did die. Furthermore, the theory conflicts with our understanding of time, making it controversial for many years. However, recent thought experiments have renewed interest in the theory's potential. Apart from the many worlds theory, there is another theory called string theory that also proposed the existence of parallel universes. Now, imagine tracing the history of the universe back to its beginning, the Big Bang. Whilst we do this, we will eventually come across the concept of parallel universes. However, we are limited in our ability to observe the universe due to a boundary in both space and time. The universe began around 13.8 billion years ago in a state of high temperature, density and matter, and has been expanding and cooling ever since. By looking back in space, we can also look back in time to the hot Big Bang's boundary. However, there is a limit to how far back we can go, as the universe would have had properties that are not observed if it had exceeded a certain temperature and density. Instead, the theory of cosmic inflation suggested that the universe was stretched to be flat before the Big Bang, which removed any problematic relics that were predicted to form. At high temperatures, the universe had a uniform energy density due to cosmic inflation, with quantum fluctuations layered on top. During inflation, there are different probabilities that the field will roll into different states, creating new space in the inflating universe. In some regions, the field rolls into a state where inflation ends, resulting in the creation of a hot Big Bang and a new universe. Between these universes is more inflating space, where inflation continues to create more space. In other regions, the field rolls into a state where inflation ends, creating even more universes and hot Big Bangs. This creates a multiverse scenario, with independent universes being born and forever separated by space that inflates eternally. It's like a cosmic dance of creation, where new universes and hot Big Bangs continue to emerge, creating an endless and awe-inspiring spectacle. Despite the fact that each universe came from the same location, there is no way to move anything between them because they are not causally linked. Although many scientists are skeptical of the theory of parallel universes, an experiment seems to have changed that. The experiment discovered cosmic rays that may have originated from outside our universe. NASA's Arctic Impulsive Transient Antenna, also called ANITA, uses a large balloon to hold sensitive electronic antennas high into the cold, dry air over Antarctica, where there is little to no radio noise to distort its results. High-energy particles are constantly blowing in from outer space, some of which are 1,000,000 times more potent than anything we can create ourselves. Neutrinos, which are low-energy particles, can pass entirely through the Earth without much interaction with our planet's substance. However, due to the Earth's solid material, high-energy objects come to a stop. This implies that high-energy particles can only be detected as they come down from outer space. Detecting a heavier particle such as tau neutrino emerging from the Earth implies that these particles are traveling backward in time, indicating the possibility of a parallel universe. Despite the interesting findings of ANITA, many scientists have dismissed the idea of parallel universes and attributed the phenomenon to other factors. However, this is not unexpected given that past astronomers also held erroneous beliefs about the universe. Although the concept of parallel universes is not to be discarded entirely, testing their existence is a challenge. One proposed method is to observe cold or hot spots in the cosmic microwave background, CMB, resulting from the collision of universes, which could be detected through advanced sky surveys. Gravitational waves, which are distortions in space-time, are also a possible indicator of cosmic inflation and could provide evidence to support the existence of parallel universes. According to the theory, gravitational waves left over from the Big Bang could create small curls in the CMB, and scientists are currently searching for evidence of this with telescopes. If these curls are found, it could support the notion that there are parallel universes where another version of yourself may exist. However, there is a link between parallel universes and two other space phenomena, black holes and white holes. Black holes are massive objects that consume everything that comes near them, while white holes expel everything inside them. These three phenomena are connected, and especially, white holes have the potential to produce new Big Bangs that could lead to the creation of multiple universes beyond our own. The physical laws in those universes are likely to differ, and reality might be composed of antimatter or have non-positive and non-unidirectional time. These universes could possibly be similar to our own, but with diverging timelines based on different quantum states, which would confirm quantum superposition. Share your thoughts on parallel universes in the comments section below, and if you enjoyed this video, be sure to give it a thumbs up and subscribe to our channel for more captivating content about science and the universe. Thanks for watching.